Hello everyone, this is Professor Roman. Welcome to the 38th video in my video lecture series, An Introduction to Discrete Mathematics. In the last video, we began our discussion of Catalan words and Catalan numbers, so let's continue that discussion now. In the last video, we began our discussion of Catalan numbers, Catalan words. So let's continue that discussion. Catalan words can be defined inductively. And so let's start with this theorem. If W is a Catalan word of length 2n, so it would be in Cn of AB, then inserting the substring AB anywhere in the word results in a Catalan word of length 2n plus 2. So in short, you can insert AB anywhere in a Catalan word and you'll get another Catalan word. Conversely, every Catalan word of length 2n plus 2 contains a substring AB, and removing that substring results in a Catalan word of length 2n. As to the proof for part 1, suppose that W is a Catalan word of length 2n, and for reasons that will become apparent in a few minutes, I'm going to write W in kind of an unusual way. The letters in W are A1 through AK, and then I'm going to skip to AK plus 3 through A2n plus 2. And you'll see why I'm doing this in a little while. I think I wrote this proof probably 6 times in totally different ways, trying to find what I thought might be the clearest proof. And this is what I hit upon. So some of this is hindsight. I already saw what was coming, so that's why I decided to index the elements of W by skipping K plus 1 and K plus 2. And as I say, you'll see why in a minute. A1 through AK I can write just as X. And so the last index, 2n plus 2, is there because this word has length 2n, but there are 2 indices missing. And suppose that we're going to insert then the string AB at this gap here in the indices. So we have X, AB, and then AK plus 3 through A2n plus 2. And we want to show that W prime is also a Catalan word. Certainly it has the same number of A's as B's because we've inserted one A and one B into the Catalan word W. As far as weak A dominance, the reason I left this gap in the indices is I want to compare W prime not to W because the lengths are different, and that makes it a little more complicated to look at the prefixes, and it's just kind of a mess. But what if we just add a third letter to the alphabet? So we have A, B, and this hyphen should be ordered alphabet. Then we can talk about A over B dominance. We have to be specific about both letters. Okay. So we're going to slip two hyphens in here where the A and the B are. And so we're going to look at W double prime and compare it to W prime. Remember, we're trying to show W prime is a Catalan word. If we can show, we've already said that there are the same number of A's and B's, so that's taken care of. We just have to deal with weak A dominance. Well, this word is still weakly A over B dominant. There are always at least as many A's as there are B's in any position in this word, because the hyphens don't contribute to the A count or the B count. Now everything is aligned properly. Both words have the same length, and we can compare prefixes more easily. Okay. So, first observation, since W double prime and W prime share the same prefix X, we know that W prime is weakly A dominant at least through position K, because it's identical to W double prime. So that's the first thing to note. Now at position K plus 1, what are the prefixes? For W double prime at K plus 1, we have X and one hyphen. And for W prime, we have XA. So that's what I've written here. So the A count of W prime is one greater than the A count of W double prime. But the B counts are the same. So W prime is actually strongly A dominant at this position. At the same position in W double prime, it's weakly A dominant. We kick up the count of A by 1, we have strong dominance. For subsequent positions, K plus J, where J is at least 2, so we just beyond K plus 1, these are the prefixes. So we run from X up to a K plus J in both cases. We have the two hyphens in W double prime, and we have AB in W prime. Now, if J is equal to 2, there aren't going to be any of these. So we'll have just X hyphen hyphen, and here we'll have just XAB. That's fine. But in this case, both the A and the B counts of W prime are one greater than they are in W double prime. So, since W double prime is weakly A over B dominant, W prime is weakly A dominant at all the rest of the positions. So W prime is a Catalan word. Now let's look at the proof of part 2, where we are removing the string AB. The argument is analogous, really. So suppose we have a word, a Catalan word of length 2n plus 2 over AB, and we'll write it in this form. Now the indexing makes a little more sense. X ends with A sub k. This would take the place of A sub k plus 1, A sub k plus 2, so this is A sub k plus 3. And to do something similar to what I just did, instead of actually removing the substring AB, we're going to replace it by two hyphens. And just as before, if W prime has an equal number of A's and B's, which it does, because we pulled one A and one B out of W, and if W prime is weakly A over B dominant, then the word that we would obtain from W by actually removing the substring AB would be a Catalan word, which is what we're trying to show. Okay, well, again, clearly W prime has an equal number of A's and B's. Also, W prime is weakly A dominant, I should say A over B dominant. For all positions up to K. But this is also true at positions K plus 1 and K plus 2, which are these two positions, because the A and B counts haven't changed from their values at position K, so they still have the same relative sizes. All we have to look at then are the positions K plus J, where J is at least 3. But the number of A's in W prime, so we're looking at something like this, the number of A's in W prime up to that point is the number of A's in W up to the same point minus 1, because we've lost this A. And the same thing for B's. We lose this B, so the A and B counts in both cases are the same, or are 1 less than they were in W. Okay. And so if both of these counts drop, and after they're dropped by 1, the A count's bigger than or equal to the B count, it is also on this side. So W prime is weakly A dominant. It's a little bit of a subtle proof, a little tricky, so it might take going over a couple of times if you're interested in learning, really understanding it. And as I said before, I've rewritten this many times because there are a lot of ways to write this proof. Well, this theorem that we just discussed tells us that the Catalan words can be defined inductively, and here it would be the inductive definition. I didn't write it as a definition because we've already got a definition for Catalan words, so this is written as a corollary to the previous theorem. A word over the alphabet AB is a Catalan word if and only if it satisfies the following. AB is a Catalan word. If W is a Catalan word, then so is the word formed by inserting the string AB anywhere in the word. And nothing, this is the limiting clause, nothing is a Catalan word unless it can be obtained by a finite number of applications of statements 1 and 2. So that's the traditional definition by induction. And the proof is very short. I will let you should think about it yourself, and you can read what I wrote here. Now, I've recorded a few simple properties of Catalan numbers that we may want to refer to or not. They're more or less direct consequences of the formula for the Catalan numbers. This is another way to express them, kind of like this. It's nicely symmetric in a way. 2n, choose n, minus 2n, choose n minus 1. Catalan numbers can also be written as a sum of the squares of binomial coefficients. And here is a non-linear recurrence relation for the Catalan numbers. And I'm going to leave proof of parts 1 and 3 to you and prove just part 2. And that is done by using a relatively famous formula called the Vandermonde convolution formula for binomial coefficients, and it looks like this. And this formula has a rather easy combinatorial proof. So in order to choose p balls, let's say p balls from a set of n plus m balls, we can separate the balls into two groups, one of size n, the other of size m, choose k balls, choose k balls from the n, group of size n, and choose the rest from the group of size m. And that is a way to do all of these choices. Okay? And so that's where the formula comes from, the van der Waals convolution formula. And we can use that here in the expression for the Catalan numbers, and that will give us this expression here. Now the Catalan numbers also have a nice recurrence relation, so let's investigate that. It is somewhat more pleasant than this recurrence here. So I'm going to write Cn for Cn of AB, because throughout this discussion the letters will be A and B. And the key to finding the recurrence relation for the Catalan numbers is that all Catalan words, W in Cn, can be written in this form, AXBV, where X is a Catalan word in CK-1, and V is a Catalan word in Cn-k. So this is a decomposition, which is often the route to finding a recurrence relation. And to see that this is the case, first, we know that Catalan words have to start with an A because they're weakly A dominant, so they can't start with a B. Also, all Catalan words must have a tie at some point. In fact, they have a tie at the end point because there are equal number of A's and B's. So now we look at the first occurrence of a tie. And let's suppose that occurs at position 2k. It'll be an even position, even numbered position. So W then can be written as a prefix of W of length 2k followed by V. And V is a Catalan word in Cn-k because we are, in effect, if we start at the first letter in V, we're restarting the counts because there are an equal number of A's and B's in the prefix. So we just kind of reset that to 0 and then start counting from the first character in V. Because 2k is the first tie position, the prefix here is strongly A dominant right up to the end. There's no ties in this region from the first character to the character at position 2k-1. There are no ties anywhere, and the tie comes at position 2k, and so there actually have to be more A's than B's, strictly more, up to and including position 2k-1. So the prefix W sub 2k looks like AXB. B is where we hit the tie, the first tie. It has to be with a B. And X is weakly A dominant. And the number of A's in X equals the number of B's in X. So X is in CK-1. So we have our decomposition of W into AXBV. So that is this. Now, if Cn, 2k is the family of Catalan words in Cn whose first tie position is at 2k, then we can define a map. And the map just takes W and strips away A and B, and leaves X and V, and we put it in an ordered pair. Okay, so this is a map from Cn, comma 2k. Again, this is the Catalan words of length 2n, whose first tie position is at 2k, can be mapped to Catalan words in Ck minus 1, comma, Catalan word in Cn minus k. This map is certainly injective because this decomposition can be restored. We can put the A back in front of X, the B in front of V, and drop the comma, and we come back to the word we started with. It's also surjective because every ordered pair of this type can be recomposed into a Catalan word, which then gets sent to that ordered pair. So we have a bijection here, theta. That means the size of Cn2k is the size of this Cartesian product, which is the product of the sizes. Now this only applies to Catalan words of length 2n that have their first tie at 2k. So we need to sum on k from 1 to n. That will give us all of the Catalan words of size 2n. So the number of such words is the sum of this product as k goes from 1 to n. And so just a little index translation here, and we get this recurrence. Cn is the sum, k, excuse me, k goes from 0 to n minus 1 of ck Cn minus k minus 1. Well, now comes a decision I have to make. We're at about the 22-minute mark in this video. I thought maybe I'd be able to finish the discussion of Catalan words, but we're now about to talk about the different types of mathematical objects that are counted by Catalan numbers. And there's several that I want to discuss, and it will, if I do it in this video, it will make this video rather long. So I think I'm going to stop this video here, and we'll pick up with the Catalan words and paths in the next video, and we'll be able to complete our discussion at that time. So thank you for watching, and I hope to see you in the next video.